Hi everyone, welcome to Creative Design and Innovation lesson. My name is Noha Abu Ali. I'll be your guide through this video to talk about neural networks, working and applications, from chapter Artificial Intelligence to section Neural Networks. The main learning objectives of this lesson are to describe what neural networks are, to understand how neural networks work, and to study some applications of the neural networks. At the beginning, let's have a look at some keywords. Artificial neural network is a series of algorithms that aims to understand the relationships in a set of data using a process inspired by the human brain. Neuron, or a nerve cell, is the main unit of the human brain and the nervous system, which are responsible for receiving, sensing data, and sending commands to our muscles. Perceptron is a mathematical model of the biological neuron of the human brain. It's considered as the core processing unit of the artificial neural network. Layer is a set of neurons which receives weighted inputs, transforms them with a set of functions, and passes it to the next layer. Error is an indication of the difference between the expected and the predicted values. Now, let's start. What is a neural network? Artificial neural networks, usually simply called neural networks, are systems developed by the inspiration of neuron functionality in the human body. A neural network is the piece of a computing system designed to simulate the way the human brain analyzes and processes information, which will replicate the way we humans learn. Neural networks form the base of deep learning that is based on the algorithms inspired by the structure of the brain. These networks take in data, train themselves to recognize the patterns in this data to be able to give a correct predicted output for a new set of similar data. Neural networks make up the backbone of deep learning algorithms, which is a subfield of machine learning that is in turn a subfield of artificial intelligence. It represents incredibly exciting and powerful machine learning-based techniques used to solve many real-world problems. Let's see an example. Imagine yourself at a field trip to a foreign country, where you cannot understand its language. If you have done your research before traveling, then you might have heard about Google's real-time translation. Other applications such as facial recognition and stocks predictions are great examples on neural networks. And now, let's see how neural networks work. Neural networks consists of several nodes which behave as neurons. The neurons are connected together by links for communication with one another. A neural network includes a huge number of neurons working together to form the core processing units of the network. Neurons are arranged in layers. The first layer, which is the input layer, receives the raw data as input. The final layer, which is the output layer, predicts and generates the output. In between, the hidden layers, which perform most of the processes and computations. For example, a neural network which predicts whether the provided image is for a cat or a human would take the image as pixels and feed each pixel into an input neuron in the first layer. Neurons of the first layer are connected with the next layers through channels. Each of these channels is assigned a numerical value known as weight. The inputs are multiplied with the corresponding weights, and their sum is sent to the neurons in the hidden layer. Each of these neurons is associated with a numerical value called the bias, which is then added to the sum. This value is then passed to an activation function, which decides whether the neuron is activated or not. The activated neurons pass the data to the neurons in the next layer through channels, following the same process as the previous layer. This is called forward propagation. At the output layer, the neuron with the highest output decides the prediction of the network. It's clear that the neural network has delivered a wrong prediction. It predicted a cat, whereas the picture is of a human. This is normal, of course, because our network is yet to be trained. During this training process, the network compares the predicted output with the actual given output by the trainer to calculate the error. The value of the calculated error indicates how wrong we are, and the sign indicates whether we are higher or lower than the correct prediction. This information is transferred back to the network, which will update the weights. This is known as backpropagation. This cycle of forward and backpropagation is done repeatedly with multiple inputs until the network can give correct predictions. This brings our training process to an end. Neural networks do not memorize the data as it is. It mainly learns the relation between the input data so that when it is tested with different data that it was never trained on, it can predict correct solutions. Let's move to the applications of the neural networks. Most of business applications and commercial companies make use of neural networks technologies. Their main aim is to solve complex problems. They attempt to model human intelligence by simulating the brain structure and function to achieve superhuman performance. One of the popular applications of neural networks is facial recognition, which includes face detection that involves finding one or more faces in a photo. Also, nowadays cameras of smartphones can estimate the age of a person based on their facial features. First, it separates your face from the surroundings, then it correlates the lines and spots on your face to estimate your age. Another important application is stocks forecasting, which has always been of great interest for financial markets. Neural networks has proved its ability to understand the patterns and changes in data, which makes it capable of accurately predicting the rise and fall in stocks. Another application is music composition. Neural networks can even understand patterns in music and train itself on these patterns to reach a level where it can compose its own music. Automatic music composition can generate long musical compositions with many different instruments, which will instantly decrease music production costs and improve the efficiency of music creation. Now, it's your turn. Use your knowledge and research skills to identify 3 more applications of neural networks. Please pause the video to do the activity. Here are some suggested applications. Finally, let's recap the learning objectives. During this video, we understood what a neural network is, we learned how neural networks work, and we explored some applications of the neural networks. At the end, I hope you have enjoyed the lesson. Thank you for watching and see you in the next video.